Okay, hi guys! In the last video, we covered a few basic definitions for when you're starting out with stoichiometry, like moles, Avogadro's number, molar masses, and I'm pretty sure we covered the formulas. So just a quick review. Both of these formulas over here, they're a way to find the number of moles. Of course, you can rearrange them as needed. So for this formula over here on the left, if you divide the given mass of a substance by the molar mass of a substance, you'll get moles. And over here, if you divide the number of particles of a substance by Avogadro's number, which is a given, it's 6.02 times 10 to the 23rd power, you'll get the number of moles of that substance. So we're going to go over some basic problems here just so that you can get comfortable with using these formulas. So just to review, molar masses are the mass that a substance would have in 1 mole of it. If you look at the periodic table that I have over here, there are these numbers at the bottom of every element, and that's known as the atomic mass. When we're calculating the molar mass is actually the same as the atomic mass. The units are the only thing that's different. So atomic mass, the units are AAM, and then for molar mass, it's grams per mole. So just as a visual example, if I wanted to calculate the molar mass of just 1 mole of helium, I would just look at the periodic table. The average atomic mass for it is 4.003, and that is actually equivalent to the molar mass. So 4.003, put that into grams per mole. I would just change the units from AAM. So for every 1 mole of helium, I would have 4 grams of helium. So this problem, it's a little bit different. Now here we have a compound instead of just a single element. And in this compound, the charges are also exchanged. So sodium sulfide is written as Na2S. It's not just Na or just S, it's Na2S. So you would want to take the average atomic mass that's listed on the periodic table. For example, sodium has an AAM of 23 and sulfur has an AAM of 32, I believe. So you would take those average atomic masses and then you would look at the amounts of the element present in the substance. So for example, Na is 2, whereas S is 1. So then I would do 23 times 2, and then for sulfide or sulfur, I would do 32 times 1. Then after I have those separate calculations, I would add them together. So here's the answer for the problem. 23 times 2 for the sodium side, and then adding 32.1 for the sulfide side, or the sulfur side, is equivalent to 78.1 grams per mole. So the whole substance, if you took 1 mole of sodium sulfide, that would be the mass of it. And again, remember, you take the amounts, you multiply them by their average atomic masses listed on the periodic table, and then you add each element in the compound together. So this problem, same idea. So I'll take away the covering in 5, 4, 3, 2, 1. So for like hydrated metal compounds, you do it a little bit differently in that the first half of the compound, like for example for copper sulfate here, you would do the same thing. You would do the average atomic mass of copper multiplied by its amount, and then you would do the same for the sulfur. You would do the average atomic mass of oxygen multiplied by its amount, so that's 4. So over here it's 63.5 for copper plus 32.1 for sulfur plus 4 times 16, because 16 is the AAM of oxygen and there's 4 of it present. So you'd multiply that and then you would keep those to the side. On the other side with the H2O, you would first find the molar mass of H2O itself, which is 18, and then you would multiply that by the 5. So by the coefficient given. Add all those up. So over here you have 159.6 plus 90, and that gives you 249.6 grams per mole. So moving on for molar masses, hopefully by now you have a good understanding of it. Let's go look at the formulas that I had explained earlier. So in this problem, we're asked how many atoms are in 12 moles of carbon dioxide. So over here, you would have to think, okay, which of these formulas do I use? I'm given moles and I'm given substances, but I'm asked to find the number of particles, in this case, atoms. So I would use the formula on the right, which is N is equal to number of particles divided by Avogadro's number. I would plug my numbers in, rearrange as necessary, and I'll move the covering in 5, 4, 3, 2, 1. So again, the formula has been rearranged, so we have to find the number of particles by multiplying Avogadro's number by the moles given. So that's 12 times 6.02 times 10 to the 23rd power. Multiply that all together, and we find that in 12 moles of carbon dioxide, there are 7.224 times 10 to the 24th power number of atoms. Okay, new problem here. We're given substance, we're given moles, and here we have to find atoms, so a kind of particle. We know to use the formula on the right. So it's kind of the same as the last problem. You take information, plug it in however it needs to be plugged in, But this is a little different because we're not trying to find the total number of particles of the whole compound. We specifically are trying to find the number of hydrogen atoms present in H2O. Before I move the answer, try it yourself, obviously. To solve this, look at how the actual compound is written out. It's H2O. That means for every one oxygen, there's two more hydrogens. That is the extra step you will take when you're solving this problem. You will have to increase the amount of particles that you found of the total. You'd want to increase that by the amount of hydrogen atoms there are present. So I'll move the cover in a second and you can try it on by yourself. You can see over here, we went through the motions, plugged in your numbers, and 4.21 times 10 to the 24th power, those are the total number of atoms or particles present in H2O. To narrow it down to hydrogen, to specialize it to just say how many hydrogen atoms there are, we would multiply it by the amount of hydrogen present in the whole compound. So if it says H2O, we would multiply that total amount, that total number of atoms, by 2 to get 8.428 times 10 to the 24th power number of hydrogen atoms present in the compound. If the compound was H3O, we'd multiply 4.21 by 3, and so on and so forth. Like, that's how you would solve this kind of problem. Finding the number of moles when we're given a mass and the compound. So over here in this problem, we're asked how many moles there are in 10 grams of hydrochloric acid. Here, we would analyze the information we're given and we'd think, okay, well, we have the compound given, but on top of that, we have a mass given. That prompts us to use the formula on the left. I'll move the cover. You can probably figure it out. This one is simple. You just plug in the numbers. So I'll move the cover in 5, 4, 3, 2, 1. Okay, so the reason that this problem is written out a little bit differently than you would expect, you would probably have just put the numbers in that formula way and then solved, gotten your number. But the reason that we write it this way is because this is how more complicated stoichiometry problems are going to show up. They're written in this ratio sort of way so that we can understand how the units cancel out to give us the answer that we want. So here, where it's mass divided by molar mass, we write it out such that the given amount is put on the left side. So we start with our given amount, okay? And then after that, because we have to get from mass and molar mass to moles, we would just think of it as like stretching out the formula. You're just extending the formula. So we would write 10 grams of HCl multiplied by 1 mole of HCl, and that's written over 36.5 grams of HCl. In truth, that's just molar mass. 36.5 grams per mole would be the typical way to write the molar mass of HCl. But here we've written it in such a way that the 10 grams of HCl will cancel out with the 36.5 grams of HCl, sorry. So that will leave us with just the numbers and the unit moles. So when we do all this cancellation, we do all our work, just cross those two units out, and we end up with 0.274 moles of HCl. The concept I really want to stress to you is unit cancellation, because Stoic, more than just numbers, you need to know how to set up your equations in such a way that this unit cancels out with that unit, and it leaves you with the units that you want. So in this example, we took the units that we were given, put it at the side, and then we set up the whole equation so that the units that we wanted were over the units that we already had. My chemistry teacher, when teaching this concept to the class, would just repeatedly yell, like every 5 minutes, "What you want over what you have." And she was right, because that's how you solve these problems. Next one. All right, by now you know how to do this. Look at the information you've been given, figure out your formula, but I will tell you before I move the answer, try and solve it yourself, and remember to use that form that you used or that you were shown on the previous problem. That form of allowing you to set up your units to be canceled and putting what units you want over what units you have. So pause if you want to try it yourself, and I'll move the thing in 1, 2, and 3. By now, again, you should be more comfortable with this form. Practice more, find other videos online. If you don't practice, you're never going to get comfortable with the concepts like you need to. But back to this, 6 moles of HCl, which is our given information, multiply it by 36.5 grams of HCl over 1 mole of HCl. So here, the problem is flipped because we want to end up with grams. So what we do is we cancel out moles and moles. That leaves us with just numbers. Numbers multiply or divide or do whatever they need to do. And that means that we have 219 grams of HCl in 6 moles of it. Okay, so like I said, that was our last problem. You're done, you can have peace. But before that, thank you so much for watching. I really hope this video helped you guys out. If it did, like, subscribe, you know the drill, grow my channel. But yeah, everyone have a good day. Bye!